Hey guys, this is Dr. Brown here again with Kubo Math coming to you from Tarlac City, Philippines. Hopefully everyone's had a good day and we're ready to jump into some Algebra 1 exponents. Hey, let's get on it. Okay, so here, as you know, I'm big into the rules. It's all about the rules. If you can understand the rules, you can do the work. So let's study the rules. Any number raised to the 0th power is 1. This could be 5 to the 0, it's 1. It could be a billion raised to the 0, it's 1. It doesn't matter. Okay, any number raised to the 0 power is 1. In this case, I'm showing a to the 2nd power. What does that mean? It means a, whatever this number is, times itself 2 times. So in this case, this would be a times a. If this were a to the 3rd power, it would be a times a times a. A times itself 3 times. If I have two different exponents, now I have a raised to the m power times a raised to the n power. And that equals a to the m plus n. So I'm just adding those exponents. So if this was a to the 2nd power times a to the 3rd power, that would equal a to the 2 plus 3 or a to the 5th power. And there's other ways to do that. We'll talk about those, I think, over there. Okay, now I have a to the m divided by a to the n. So while I was multiplying all of these here and adding the exponents, now I'm dividing, so I will subtract the exponents. This would equal a to the m minus n. So if I have a cubed divided by a squared, it's a to the 3 minus 2 equals a to the 1, or just a. Now you could say a to the 3rd power is a times a times a divided by a to the 2nd power, which is a times a. A divided by a is 1. If you say 0, I'm coming to your house. A divided by a is 1. A divided by a is 1. 1 times 1 is 1. Again, if you say 0, I'm coming to your house. 1 times 1 is 1. 1 times a equals a, which is what we had. So there's other ways to go about this, but obviously remembering the rules is a little bit easier. Now in this one, I can expand this a little. This is the same as a to the m divided by b to the m. Sometimes you may see the terms like this and you need to collect it and go about it here, especially when we get into logarithms. That would become important. What would be an example here? Let's say I have, see if you can see this, 10 over 5 squared. Whoa. Okay, 10 divided by 5 is 2, so that's 2 to the 2nd power. 2 times 2, well, that means 2 times 2, right? This number times itself 2 times, so 2 times 2 equals 4. 2 squared is 4. Okay, if I were to expand that, it's saying I could have 10 squared over 5 squared. Well, 10 squared is 100. 10 times 10 is 100. 5 times 5 is 25. 100 divided by 25 is 4, which is exactly what I had here. So this works out. I would encourage you to, when you forget the rules, do something simple like this that you know and see if the things work out for you so that you know you've properly remembered the rule. I do that often, especially as I've gotten older. Okay, AB to the m, the parentheses of AB raised to the m power, is the same as a to the m times b to the m. Let's see, what would be an example here? Let's say 3 times 2 raised to the second power. Okay, 3 times 2 is 6. 6 to the second power is 6 times 6 is 36. So they're saying that's the same as 3 squared times 2 squared. So 3 times 3 is 9. 2 to the second power is 4. 9 times 4 is 36. So that worked out. Yay. Okay. This is one when I was in high school. I don't remember seeing this. Maybe I was looking out the window that day. It's highly likely. Okay. A to the m, and then that parentheses raised again to the nth power. And that means it's a to the m times n. So if I have, let's say, 2 to the third power squared, that would be the same as, we could do this one way, 2 times 2 times 2, that's 2 to the third power, squared, which means I have 2 of these. So 2 times 2 times 2. Okay, 2 times 2 times 2 is 2 times 2 is 4, times 2 is 8. So that would be 8 times 8 equals 64. All right, so let's see. This would be 2 times 3 times 2 is 2 to the 6th, which how many 2's did we have? 1, 2, 3, 4, 5, 6. So that would be correct. Okay? So a to the m raised to the n is a to the m times n. Okay, so these are the rules of exponents. Let's see how that applies to some actual problems. We'll work these on the right first, and then I'll erase them, and then that'll give us room to work these others. T times t. I have t times itself 2 times. So that's t to the second power. That number times itself 2 times, which is exactly what I have here. Okay, t to the second power times t to the third power. Which rule does that fit? Okay, a to the m times a to the n is a to the m plus n. So now I have t to the 2 plus 3 equal t to the 5th power. Again, I have 2 of these t's and I have 3 of those. You just count the t's, there's 5 of them. A to the second power times a to the second power. Again, this is a to the m plus n. It just happens to be that m and n are equal. So that's a to the 2 plus 2. That's a bad 2, equal a to the 4th. Okay, what about a plus b times a plus b? Well, if I imagine for a moment that everything in this parentheses is x, which means everything in that one is x. Oh, it's, how many x's do I have? 2. It's x times itself twice. So this is x to the second power. Well, what is x? It's a plus b. So this would become a plus b to the second power. Okay. Sorry, I got a little messy there. So that's a plus b to the second power. What about this one here? I have 2 parentheses inside of a parentheses, but the major parentheses is squared. So I have 2 times the parentheses of a plus b. Now you'll recall we have this situation here, and we can expand that to this. So let's do that. That would mean I have 2 squared times a plus b squared. So which would be 4 times a plus b squared. Now we haven't learned, I don't think, in Algebra 1 how to FOIL something just yet, but we will. But for now, it would just be using this rule, AB raised to the m is A to the m, B to the m, which is what we've done there. Okay. All right, if you need to take a screenshot, take it now. 3, 2, 1, here we go. I'm going to erase these. I guess on YouTube you can just rewind. Okay. All right. Now then, 17 to the 0th power is... I don't hear anybody. Oh, it's 1. Any number raised to the 0th power is 1. Now I have 3 to the 6th divided by 3 to the 4th. Well, I have this rule right here. A to the m divided by A to the n is A to the m minus n. So this equals 3 to the 6 minus 4 equal 3 to the 2nd power. Now I could say 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5, 6 divided by 3 to the 4th. Okay, that's 1. 3 divided by 3 is 1. 3 divided by 3 is 1. 3 divided by 3 is 1. 1 times 1 times 1 times 1 is 1 times 3 times 3. So this is 3 times itself twice equals 3 to the 2nd power. Okay. Oh, what about this guy? Now we have multiple rules. In the numerator, in the top, we have 3 to the 2nd power raised to the 2nd power. So remember the rule, A to the m raised to the n is A to the m times n. So here I have 3 to the 2 times 2, which is, and then divided by 3 to the 3rd power. So 3 to the 4th divided by 3 to the 3rd. Now then, I've got this rule here that I can work with now. I have 3 to the 4th divided by 3 to the 3rd. So 3 to the 4th minus 3 equals 3 to the 1st power, equal just 3. And this makes sense in the fact that 3 times 3 times 3 times 3, 3 to the 4th, divided by 3 to the 3rd, 3 times itself, 3 times, 1, 2, 3, 3 times itself 4 times, 1, 2, 3, 4, it leaves me only 3. Okay. Okay, we have one, this one is very similar to the one above, so now we have x times raised to the 2nd power, then that raised to the 3rd power, so that's x to the 2 times 3, following, where'd the rule? Yeah, this one here, divided by x to the 4th. So I have x to the 6th divided by x to the 4th, and that's x to the 6 minus 4 equal x to the 2nd power. So I used this rule. So I used two different rules. This one here for the numerator, and then when I expanded it into this fraction here, then I used a to the m divided by a to the n. So these were just some simple examples of exponents that have huge implications as you go through your math journey. Learn the rules. I'll say it every video. Study the rules. You can't play the math game if you don't know the rules. Well, you can, but you will not be so successful. So hopefully these help you. Study them. Study the algebraic rules we had in the first video. Sorry for the fan noise in that video. But study those, and then we're going to keep adding to our toolbox of knowledge so that we can be successful in math. So together, let's build a better tomorrow, and let's do that through math. Have a great evening, and we'll talk to you soon. Thank you.